एक्टिव स्ट्रीम किया था पीपीटी को? आ रही है ना पीपीटी? यहाँ पे क्लिक करें ठीक है सर।
अब एक्टिव स्ट्रीम करना।
हाँ
अब आया। पहले कर दिया था।
ठीक है सर।
चलिए।
बोला ही हो गया।
A very good morning to all the participants. Myself, Khwaja Ahmad. Today we are going to discuss about linear measurements and types of linear measuring instruments, angular measurement, types of angular measuring instruments, and last, interferometry. As we know that measurement of perpendicular distance between 2 points or surfaces is very utmost important in this particular scenario of interchangeability. These instruments which we are going to learn about, they are either designed for line measurements or in measurements. Linear measurements include the measurement of lengths, diameters, heights, and thickness. And the basic principle of linear measuring instruments of mechanical type is that of comparison with standard dimension on a suitably engraved instruments or device. What does it mean? It means that if we want to compare the unknown, then we have to use the standard engraved instrument or any device so that we can get the value of the unknown. Similarly, linear measuring instruments are different types. They are categorized accordingly depending upon various their parameters. Generally, they are categorized as non-precision instruments and precision instruments. Similarly, they are also categorized as direct measuring instruments, indirect measuring instruments, or they can be categorized or they can be clubbed as absolute measuring instruments like steel rule, vernier caliper, etc., or comparative type of instruments like dial indicators and optimeters. Similarly, they are also classified as contact type and non-contact type of instruments. In contact type, we are having micrometers, calipers, dial indicators. In non-contact type, we are having tool makers, microscope, or comparator, etc. They are also divided or categorized as non-precision instruments and precision instruments. Non-precision instruments generally they include steel rule, calipers, dividers, and telescopic gauges like that. And they are used to measure the line graduation of through a line graduation on a rule. Precision instruments include micrometers, vernier, calipers, height gauges, slip gauges, etc. Similarly, a wide variety of electrical measuring devices is also available. Electric measuring devices are mainly transducers. Generally, they are transducers. They transform the displacement to suitable measuring parameter like voltage and current. Here you must be having this idea about the types of types of standards generally we are using. The types of standards which we are using are so first try to understand this, that the length may be expressed as the distance between two lines or as the distance between two faces. What is the length? Length is nothing but the distance between either two lines or between two faces. So the instruments which we are going to use for this direct measurement of linear dimension they fall into two categories. One is known as line standard, another one is known as end standard. In the line standard, the measurement is made between two parallel lines engraved across the standard. The most common example of this line standard is the line measurement is the steel rule, where you are using the steel rule to get the dimension between two engraved lines on the across the standard. Similarly, what is end standard? End standard is nothing but here you measure the distance between two parallel flats faces. Uh, most best example is your slip gauge, micrometers, vernier calipers. They make the distance between two parallel faces. So line standards and end standards are there, and depending upon this line standard and end standards, the instruments can also be categorized. So we have categorized here for our simple understanding the instruments into non-precision instruments and precision instruments. Major instruments can further be classified, as I have already told, graduated instruments and non-graduated instruments also. These are some of the graduated instruments. Here you can see this is a vernier caliper, this is micrometer, this is your height gauge, this is your depth gauge. They are having graduation. Here you can see that the upper scale showing imperial values and the lower one is showing the metric value. Similar is the case here with the micrometer. It is showing some graduated marks on it. Similar is case with the depth gauge and height gauge also. Before entering into and trying to understand what are the various types of instruments, two most important things which are there and which are the part and parcel of the metrological lab and the measurement lab is the surface plate. The surface plates are one of the most important part where you can place the part which you want to measure on this surface plate, which are very flat, and on that particular part, on that particular surface, you can put down your parts and you can use those surface plates for measuring the exact values of the part which you want to measure. The surface plates are available in various materials. Generally, they are made of cast iron, granite surface plate is also available, glass surface plates are also available in the market, and of different materials the surface plates are also available. And along with the surface plate, there is one more important part which need to be used along with the surface plate, that is V block. When V blocks generally come into pairs, where if the part is more the length of the part is more, then you can place that part on the two V blocks, and these two V blocks they can be these two V blocks they can be placed on the surface plate. Similarly, if the part to be measured is of cylindrical type, then you can place the part on cylindrical part on this V block, and you can fix it with the nut, and you can place that both the V blocks on this particular surface plate, so to measure the given component. So one of the most important part and of the metrological lab is surface plate and V blocks. Surface plate, as I have already told you, it can come into different materials, and they are having characteristics of their own. Generally, cast iron surface plates are generally used in the workshop because damage to the granite or glass surface that causes indentation marks, and whereas on the cast iron plate it is of less damages can occur. Second, in granite, corrosion is virtually absent, granite or glass, and it is easier to slide metallic articles on the granite and glass. But cast iron is most preferred material for surface plates and surface tables because of various properties of the cast iron, that it is self-lubricating and the equipment slides on the working surface with a pleasant feel. Second, it is easy to provide complex shape of stiffening ribs. The ribs are provided below the flattened surfaces for stability purpose. Third point in favor of cast iron, it is stable and rigid metal, and relatively it is inexpensive. And last point which can be covered in favor of cast iron is that it is easily machined and scraped to an accurate plane surface. and I have already told you about the V blocks. Now, non-precision measuring instruments. These are limited to the measurement of parts to a visible line graduation on the instrument. Here, when we use non-precision measuring instruments, high measurement accuracy is not required. One of the most important non-precision measuring instrument is the steel rule. It is the most simplest and most common measuring instruments in the workshop or the inspection area. The principle behind steel rule is that of comparing an unknown length to the one previously calibrated one. The rule here for steel rule is that it must be graduated uniformly throughout its length, either in metric units or in imperial units. There are rules that have got some attachment and special features with them to make their use more versatile. What are those other rules? Here we are going to see. Here you can see that this is a imperial. This scale is showing imperial units, 1 inch, 2 inch, 3 inch, and this scale is showing metric units, 10 mm, 20 mm, 30 mm, and one of the most important thing which we must remember over here while using the steel rule, that when we want to measure the part, then it should be aligned with the part itself in this fashion. So this is the correct way of measuring the unknown with the known graduated scale. This should not happen. This type of measurement is wrong process of measuring any unknown surface with the known surface. Here we can see the third point. Here the another point which have to be remembered by the inspector is that when we are using the graduated scale or any type of scale for measuring the unknown or comparing the unknown with this graduated scale, then position of the eye, it plays a very important role. So here you can see there are 3 positions, out of which only one position is the correct position of measuring. Otherwise what will happen, you will get the parallax error, and these parallax error, they will give you wrong readings. From this figure you can understand how a parallax error, if the reading, if the point were coinciding with the graduated scale of the unknown, if they are look from different angles, then what will happen, you will get different readings over here. But if the eye is exactly in coincidence with this particular point which you want to measure, then there will be no parallax error and you will get the right amount of reading over there. So while using the steel rule, this must be taken into account. Another non-precision instrument is the wire gauge, screw pitch gauge. Another type of non-precision instrument is a calipers. Calipers are used to measure the parts. With the help of calipers, we can measure the parts very easily. They are of different types. The calipers are of different types, and the calipers generally the calipers consist of 2 hinged legs at the top, two legs with those are hinged at the top, and the ends of the leg span is the part to be inspected. Calipers are of different types which we are going to see in the next slide. So here from this you can see that these are all the different types of calipers, and here these legs, the opening of the legs is inside. So these legs, these calipers are used to measure the outside parts, and these calipers are broadly classified as outside calipers. And there are different types of calipers in outside calipers also. One is this firm joint caliper, second one is spring caliper, third one is transfer firm joint, adjustable firm joint. These are the legs of the caliper, and this is the handling grip. This one is the handling grip, and these are the spring type of calipers. Are here spring is provided and nut is provided to lose and tighten the gap between these two legs, so that the exact dimension of a unknown can be measured. Outside unknown dimension can be measured with this. Similarly, second type of calipers are known as inside calipers. Here the legs are curved outside. So these curved legs are used to measure the inside of any particular component. These also comes into various categories. One is the firm joint, adjustable firm joint, transfer firm joint, spring type of calipers, same spring type of calipers where these are the spring and nut which can be used to loosen and tighten the gap between the legs. Another important type of caliper is hermaphrodite calipers. These hermaphrodite calipers are of two various types. Two types are shown here: adjustable point and solid point. This is the adjustable point, and this is the fixed point or the solid point hermaphrodite calipers. Now, spring calipers are attached with spring, number one, and the working ends of each leg of a spring caliper should be identical in shape and have contact points equally distant from the fulcrum. You see over here, these are the contact points. They must be of the same shape. Either they must be in a circular form or they must be in a rectangular form. And the cross section of the leg is either rectangular or circular in shape. The calipers are adjusted to set dimensions by means of either a knurled solid nut or a knurled quick action release. These are the knurled nuts, and for which they can be used for increasing or decreasing the distance between these two legs. Here we can see that this is a outside spring caliper. This is the hoop spring provided the necessary constraint. These are the screw. This is the nut. This is the leg of the caliper. Here is the distance. This distance can be increased or decreased according to the part to be measured with the help of this screw and nut. Here one point must be remembered then, that the accuracy in measuring with the help of a caliper, it totally depends upon the inspector's sense of feel. If he is experienced one and he has used the calipers methodically, then he will be able to generate near about very accurate results with the help of calipers. Otherwise, what will happen? Extra pressure or extra force provided, that will give you the reading away from the accuracy. So most of the time, accuracy of the caliper measurement depends upon the inspector's sense of feel. He must be able to understand how much pressure should be applied and what pressure should be more than enough for measuring the outside diameter. Similar is the case with the inside spring caliper. They are designed to measure the inside dimensions, and inside the spring caliper is exactly similar to an outside caliper with its leg bent outwards. In inside type of calipers, the legs are bent outward. Adjustment is then is generally made by knurled solid nut. This knurled solid nut will be able to make the necessary adjustment between these two bent legs. These types of instruments are used for comparing or measuring hole diameters, distance between shoulders, or other parallel surfaces of any inside dimensions. Firm joint type of calipers are identical in shape with contact points equally distant from the fulcrum and joined together by a rivet. There is no spring in, but they are joined by a rivet. They work on the friction created at the junction of the legs. The component part of the caliper should be free from seams, cracks, and must have a smooth finish. Firm joint calipers are further divided as outside, inside, transfer, and hermaphrodite of calipers. From here you can see these are two firm joint calipers where the two legs, either of the inside calipers or the outside calipers, the two legs, they are attached with a rivet. They are here, the rivet is there, which can be able to increase the distance between these two legs and these two legs. These are the outside type of firm joint caliper, and this is inside firm joint caliper. Similarly, hermaphrodite calipers are also used. They are of one most important calipers in the workshop. It is also known as an odd leg caliper. Why odd leg caliper? Because one end or one leg of the this embroidered caliper is the divider, and one leg is the this it is used for any it is having some notches on it, so they are used for finding the central of a cylindrical work, or it can be used for marking the parallel lines with the another plane. Here you can see that these are different types of embroidered calipers. Here one end is divider, another end is the fixed notch. They are used here for setting the marking. For here you can see how I'm marking, how the distance can be set with the help of embroidered calipers. Here you can see that the marked embroidered caliper is used to make a line or scratch a line on the surface parallel to this particular plane. So embroidered calipers are also one of the most important part and parcel of the caliper family. Last but not the least is the divider. A divider is also a type of a caliper, but here you see that both the points, both the legs, they are used for making or scribing on the surface. The scribe, one point is kept constant, and with the other point, the geometric form which is needed, either it is a arc, a circle, or a scratch line, that can be made with the help of the divider. Dividers are also available in various sizes from 100 mm, 300 mm, and much more. Another point which is comes under the precision instrument is the depth gauge. This tool is used to measure the depth of blind holes, grooves, slots, height of shoulders in holes, and dimensions of similar character. Depth gauge is essentially a very narrow steel rule to which a sliding head is clamped. This is the steel rule of the depth gauge, and a sliding head is attached to the narrow steel rule. The head forms a convenient marker in place where the rule must be held in distance from the point being measured. Here, this diagram shows you how the depth of this blind hole can be used or can be measured with the help of a vernier depth gauge. This one end is directly placed into the gap up till this end touches the surface of the blind hole. Then this movable head is placed on the upper part of the workpiece, and with the help of vernier scale, then we can measure the distance between these two points with the help of vernier depth gauge. Precision measuring instruments, one of the most important precision measuring instrument is vernier caliper. In vernier caliper, precision measuring instruments, they provide the accuracy up to a level of 0.0 or 0.1 to 0.01 mm, and they are mostly used instrument in workshop in this modern production era. Why? Because they give us the very accurate results within very limited amount of time, and this era of interchangeable concept or interchangeability concept, vernier calipers are generally used to control the dimension within the specified limits. Now here we can understand from this figure what is the concept behind a vernier caliper. On a vernier caliper, this is the main scale. This is the main scale, and to this main scale, this unmovable jaw is attached. To this main scale, this unmovable jaw is attached. A fixed jaw is attached to this main scale. Another one is the another jaw, which is moving jaw. It is attached to the vernier scale, and these are the part. This is the main scale. This is the vernier scale. This is the locking nut. These jaws are used for making external diameters or checking external diameters, and these jaws are known as internal jaws. They are used for checking the inside diameters. The marking on the main scales on the upper end is of imperial units, in the lower end it is generally in metric units. Similar is the case with the vernier scale also. In vernier caliper, the vernier scale has got 50 divisions, and these 50 divisions equals to 49 divisions of the main scale. And because of this variation, we can get the least count from how available of the vernier scale. That is 49 main scale division is equal to 50 vernier scale division. Therefore, one vernier scale division comes out to be equal to 0. Instead of 1 mm, it will be 0.9 mm. So that this difference between one main scale division and one vernier scale division comes out to be equal to 0.02. This is the least count of a vernier caliper. And there are while using vernier calipers, various errors may creep in. These errors may creep in due to play between the sliding jaws and fixed jaw. So it should be taken into account that there should be there should not be any play between the jaws, and there should not be any error due to wrapping of the jaws and wear of the jaws. And it should also be taken into account that errors due to incorrect observation of scale reading should be avoided. Because of these incorrect observation of scale readings may be due to some parallax error. Another important point which must be remembered to avoid the errors is to not to provide excessive force on moving jaws. If you provide more excessive force on the moving jaw, ultimately what will happen? It will give you the wrong reading. You will not be able to get the correct reading because of the extra excessive force applied on the moving jaw. Another point to be remembered to avoid the errors is to introduce if the line of measurement does not coincide with the line of scale. That has to be taken into account. Another very important measuring instrument or precision measuring instrument which is used in the workshop is micrometer. It is a very useful device for magnifying small measurements accurately. Micrometer works on the principle of screw and nut. The screw is attached to a concentric cylinder or a thimble, and the circumference of which is divided into number of equal parts. A screw is turned through nut by one revolution, and its axial moment is equal to pitch of the thread of the screw. These are the here from this diagram you can understand. This is the U-shaped frame of the micrometer. This is the fixed jaw, which is known as anvil. This is the spindle, which comes in and comes out, goes in and comes out of the barrel. Whenever it is turned, it will it will move in the linear direction, exactly coinciding with the axis of the anvil. And this is the locking nut. On the barrel, here is the main scale. On the barrel is the main scale, and on the thimble, here is the auxiliary scale is provided. Another one is this is the ratchet to provide the extra pressure on the job. And whatever dimension you have to measure, you have to put those part or component over between these anvil and the spindle, so that you will be able to get the exact value of that particular part. It must be noted over here that a screw turned by one revolution, then if the screw is turned by one revolution, this is turned by one revolution, then the movement of this spindle, axial movement of this will be equal to the pitch of the thread of the screw. This is the main scale of the micrometer, graduated on the barrel with two sets of division marks. The set below the reference line reads in mm, and above reads in 0.5 mm. Thimble scale is graduated on thimble with 50 equal divisions. Each small division of thimble represents 1/50 of minimum division of main scale. The main scale minimum division value is 0.5, hence each main scale this is the main scale, and the minimum division on this main scale is 0.5. Therefore, the least count is of this particular scale is 0.5 divided 50 is equal to 0.01. 0.01 mm is the least count of this vernier, this micrometer. Micrometers also comes in different types. Outside micrometer is there, inside micrometers, vernier micrometers, similarly depth micrometers, bench, digital, and screw thread, and different types of micrometers are available. From here you can understand the construction of the micrometer very easily. As I have already told you, this is the anvil, that is the fixed jaw, this is the spindle which comes in and out of this sleeve. This is the U frame, this is the main scale, this shows 1 mm mark, and this shows 0.5 mm marks. These are the 50 marks on the thimble, which is also a rotating vernier scale, and this is the ratchet knob. And here from this you can understand that the 0.5 graduations are there on the main scale of the vernier on micrometer, and these are the smallest graduation on the micrometer, that is 0.5 mm. If you want to take the reading with the help of a micrometer, here one example is shown. Suppose this is the part which you want to measure, cylinder whose diameter is to be measured, and it is fixed between anvil and the spindle. So the total reading will be main scale reading. Whatever this main scale point which is coinciding with this line, that will be the main scale reading, plus least count of the micrometer into readable on the whatever the reading is on, which is coinciding with the main line of the main scale. It will be then known as the it will be multiplied with the least count. Suppose here main scale reading on this is 13.5, least count is 0.01, and the 35th graduation on the thimble scale is coinciding with the axis of the main scale, then it will be 35. So the ultimate point, it will be 13.5 plus 0.0 into 35, which is equal to 0.35. 13.5 plus 0.35, the answer will be equal to 13.85. So up to 2 decimals, it gives you very accurate readings with the help of these micrometers. Similarly, another important precision instrument which is of utmost importance is the vernier height gauge. Similarly, the basic principle of the vernier height gauge of taking reading is similar to the vernier caliper, except that the fixed jaw in this case is replaced by a fixed base. Instead of a fixed jaw, here only fixed base is provided, which rests on a surface plate or table when taking measurements. So the part whose height is to be calculated is placed here, and this scribing jaw is attached to this vernier caliper, vernier scale, and this then helps in getting the exact dimension or height of the workpiece. This is the base of the height gauge. If you remove the fixed jaw of the vernier, then this is that base of the height gauge. This is the main scale, and this is also works as the guiding surface. This one is the vernier scale. This is the bracket, this is the scribing jaw, and on the main scale, this vernier scale then slides, and these are the screws for fine adjustments. As this vernier scale slides on this, then you will be able to get the reading or the height of the part to be measured with the help of this scribing jaw. This scribing jaw is then made to come in contact with the jaw, and then whatever main scale reading is there, then with the help of least count and vernier scale coinciding with the zero, that is taken into account, and you get the exact height in 2 digits with the help of vernier height gauge. A precaution is to be taken in use of vernier height gauge that it should be tested for straightness, squareness, and parallelism. Every care should be taken, particularly in case of long height gauges, to avoid its heating by warmth from the hands. The springing of the measuring jaw should be always avoided because this may give you the incorrect readings. And the base must be clean and free from burrs. Always it should be clean, and this base should always be clean and free from burrs, so that you will get the good accurate results. Another important measuring device is a telescopic gauge. It is used for indirect measurement, and it is used for measuring internal diameters of holes, slots, and grooves. It consists of two handles, two telescopic rods. These are the two telescopic rods. These are the two telescopic rods and locking screw. This is the locking screw. This is the two spherical ends. This is the tube. This is the telescopic rods. These two, and this is the spindle handle, and this is the locking screw. And these are put into any holes or slots or grooves, and these telescopic rods are then made to come in contact with both the surfaces, and with the help of this you can measure the diameter of the hole or the distance in the groove or the slot. This is one example where the use of telescopic rod is there for noting down the diameter of this particular part. Another important measuring instrument is the slip gauges. The slip gauges, generally they are accepted end standard of length in the industry. As I have already told you, there are two types of standards for measurement. One is line, another one is end standard. The end standard, they use the two parallel surfaces. So a rectangular block made up of high grade hardened steel is used, and it is of a particular size is there, and they are very carefully finished by high grade lapping to a high degree of finish, flatness, and accuracy. The opposite faces are of such a high degree of surface finish so that when the blocks are pressed together with a slight twist by hand, they will ring together. They will remain firmly attached to each other. That's the way these slip gauges are used. This is a figure which shows different slip gauges placed in the sockets. These are all the slip gauges of various heights which are available in the slip gauge set. I have used the word ringing. The ringing is the word. Ringing occurs due to molecular addition between a liquid film, not more than 6 to 7 micron thick, and the meeting surface. The ringing process is used to build up desired dimensions over a range of sizes in specific instrument. These are the way it is placed first, then they are moved in such a way that they get on with both the surfaces are rung together, so that you can get the required amount of height of this particular slip gauges. Slip gauges set comes into different values. The normal set, the values are of the slip gauge is 1.001 to 1.009. A single step of 0.001 is available, and for 1.001 to 1.009 you get 9 pieces. Similarly, another set of the slip gauge is 1.01 to 1.09. Here the step value is of 0.01, and these also comes into 9 pieces. Similarly, the third gradation is 1.1 to 1.9, and here the step value is 0.1. It also comes into 9 pieces. When then 1 mm to 9 mm range is there, and the step value is 1 mm. It also comes into 9 pieces. And finally, there is another range of 10 mm to 90 mm, and the step value is 10 mm, and then it goes up in 9 pieces. So there are nearly 45 pieces are there in the normal set. Similarly, in special set, you can see that 1.001 to 1.0099 pieces are there, and then 1.01 to 1.49 with a step increase of 0.01, there are 49 pieces, and then 0.5 to 9.5 with a step value of 0.5, 19 pieces are there, and 10 to 90, 10 pieces are there, and it comes into 9 pieces there. So in special cell, 86 pieces are there. The standard procedure is followed in selecting a slip gauges, and how a slip gauge are used to arrange a dimension, we will see from this example. Here one example is there. Consider this, we want to measure, or we want to make a slip gauge set having a dimension of 58.53 mm. So how you are going to select the slip gauges for 58.531 mm. Here is the example. First, always you have to select for this last digit, last decimal point. So it is 0.001. You have to select for slip gauge for this last digit. So 0.001 mm slip gauge is not available. Hence you have to use the 1.001 mm slip gauge. Now, from 58.531, you have selected the gauge of 1.001. So the remaining dimension is 57.53. Now you have to remove this 3. For 3, you have to select the gauge. Now again, as you select the gauge, it will be 1.03 mm gauge is there. So from 57.53, you will reduce 1.03 mm gauge. Now the available dimension will be 56.5. The next or the third slip gauge which you are going to select will be 1.5, because this 0.5 have to be mitigated, and so 56.5 minus 1.5 will provide you 55 mm distance. Then 5 mm gauge and finally 50 mm gauges are to be chosen, so that the gauges which are chosen to get this 58.531 height is 50 mm plus 5 mm plus 1.5 mm plus 1.03 plus 1.001. Hence all these 5 gauges will be runged together, and you will get an exact dimension of 58.531. All these 5 slip gauges will give you the required dimension after properly ringing them. Hence these are one of the most important precision instruments in the metrology. The application of slip gauges, they are used to check the accuracy of vernier, micrometers, whereas verniers and micrometers are themselves precision instruments. But to check the accuracy of the vernier and micrometer and other measuring devices, the slip gauges are used. And they are also used to set the comparator to a specific dimension. Slip gauges are also used for direct precise measurement, where the accuracy of workpiece is of utmost importance. And another point to be remembered here is that they are frequently used with sine bar to measure angle of workpiece, and they can also be used to check gap between parallel locations. These are some of the points in the use of the slip gauge. Now we come to another types of instruments, that is for measuring angle. These for measuring angles, the instruments which are used, then they are known as angle measurement instruments. They are line standard angular measuring devices like protractors and universal bevel protractors, phase standard angular measuring devices like sine bar and sine center, measurement of inclines, split levels, clinometer or angle collimator, comparators like auto collimator. Very important and one of the most significantly used instrument is sine bar. With the help of this sine bar and the slip gauge set, you can find out the value of you can find out the distance between length of a particular part. From this figure you can understand, this is the figure which shows us these are the slip gauges runged together of a particular height. This is the sine bar, this is the theta angle, that is the angle provided after one roller is on the surface of the surface plate, that is the datum surface, and another roller on the slip gauge height. So with the help of the dial gauge and a component which will be placed on the slip gauge, you will be able to get the values of the length of the particular component can be measured. With the help of theta is equal to sine inverse height upon length. Length is nothing but the distance between two rollers. In this way, you can very easily check the angle, or if you know the distance, then you can find out the angles, and if you have the angle, then you can find out the distance between these two points. And when the component is of large size or heavy size, then the use of the slip gauge is used in a different manner. From the figure you can see, from the earlier figure here you see the component is placed on the sine bar, on the sine bar. In the first, when the component size is small, the component is placed on the sine bar, whereas when the component size is large, then with the help of slip gauges, the sine bar is placed on the component. The limitations of the sine bar is that it is fairly reliable for angles less than 15 degree, and as the angle increases, then inaccuracy creeps in, and above 45, from 45 and above, it is impractical to use the sine bar. Second, it becomes very clumsy. Physically, it becomes clumsy to hold the sine bar in position. And another point to remember here is that the slight error of the sine bar causes larger angular errors, and a difference of deformation occurs at the point of roller contact with the surface plate and the gauge block. The size of parts which can be inspected by sine bar is limited, as I have already discussed with you. Some of the sources of error in the sine bars are distance between two roller centers. If it is not properly maintained, then error in angle measurement will be there. If the slip gauge combination used for angle setting is not proper, then again the readings will not be proper. If parallelism between gauging surface and plane of roller axis is not as per the requirement, again there are errors will be there. Error in equality of size of roller and cylindrical in the form of roller. Error in parallelism of roller axis with each other. And error in flatness of the upper surface of the bar. Another important instrument which is used for finding the angle is angle decker. This is a type of autocollimator, and it consists of a microscope, objective collimating lenses, and two scales engraved on a green glass. From this figure, you can understand that angle decker, this is the microscope eyepiece, this is the glass screen, collimating lenses are there, and the work ray is directed towards the workpiece through these collimating lenses, and when we get the reflected rays, then the various angles or various characteristics of that particular workpiece can be gauged with the help of the angle decker. An angle can be found out. Similarly, another important instrument which is used for finding the angle is vernier bevel protractor. This vernier bevel protractor is the simplest angle measuring instrument. It consists of main body, base plate, adjustable plate. This is the main body. This is the main scale. This is the dial. This is swivel plate. Vernier scale is there. Beam is there. With the help of this vernier bevel protractor, angles can be find out. The various readings are there on the main scale as well as on the vernier scale. As shown in the main scale is graduated in degrees of R. The vernier scale has 12 divisions each side of the center of 0. These are marked 0 to 60 minutes of arc, so that each division equals to 1 by 12 of the of 60. That is 5 minutes of arc division is provided over here. With the help of this, we can also calculate the angle of any particular component. The application of the vernier bevel protector is shown over here. Here in diagram A, use of bevel protector was checking inside beveled face of a ground surface. Similarly, in B and C, you can see that how the vernier bevel protector is used. The general, these are some of the instruments which we use in metrology, and they comes under the category of precision instruments as well as non-precision instruments. Now we come to another method of measuring, that is known as interferometry. Optical interferometry is nothing, it is an optical measurement technique which provides precise measurements of distance, displacement or shape and surface of object. It exploits the phenomena of light wave interference, where under certain conditions a pattern of dark and light bars called interference fringes can be produced. Fringes then can be analyzed to present accurate measurement in the range of nanometer. This is one of the most important point here. The recent development in laser, fiber optics and digital processing techniques have supported this particular field of metrology, that is optical interferometry. The application of this interferometry or optical interferometry ranges from measurement of a molecule size to the diameters of the stars. Now, some terms are associated here with this interferometry. One is interference. Interference is a light phenomenon. It can be seen in everyday life. Example, colors of oil film floating on water. In electromagnetic waves, interference between two or more waves is just an addition or superimposition process. It results in a new wave pattern. Interference. If suppose here two waves are in same phase, this is the wavelength. If the two rays are in same phase, then resulting intensity will be the sum of these two waves, or sum of the two intensity. Now, if these two waves are out of phase, then resulting intensity will be the difference of two intensity of these particular phases. If two rays having same amplitude, this is the amplitude. If two rays having same amplitude are in same phase, then resultant will be twice and result will be a bright spot. If two rays having same amplitude are out of phase, then resultant will be 0 and result will be dark spot. And these bright spots and dark spots, that is the phases of rays, amplitude of rays are generally used to create bright spots and dark spots. And with these bright spots and dark spots, various fringe patterns are available, and these fringe patterns are then used for calculating the dimension or accuracy or flatness of the particular part. Now, some another terminology is also used with this optical interferometry. One is the optical path length. What is optical path length? When light beam travel in space from one point to another, the path length is the geometric length d multiplied by n, that is the air refractive index, which gives you the optical path length. So optical path length is nothing but n, small n into d, which can be seen from this particular figure. That what is the distance between 2 points, and air refractive index between these 2 points will provide you the optical path length. Another particular point which is of very much importance in this interferometry is the optical path difference, that is OPD. If two beams, these are the two beams over here, from source, one beam is going in this direction and another beam is going in this direction. So if two beams with same wavelength, that is same frequency, travel from two different sources towards the same destination, these are the two beams, blue and red. emanating from two different sources having same wavelength, and they are going towards the same destination, taking different paths. There will be difference in their optical path, and this difference is called the optical path difference. It is very important factor in determining fringes intensity. These are optical path difference. This is to be taken into account. Another one is the visibility of interference fringes. Visibility determines the ability to resolve interference fringes. It depends on the coherence degree between the recombined waves. What is coherence? Coherence of light wave is defined as the correlation between the electric field values at different locations or time. The coherent light source is able to produce a coherent wave able to interfere with each other. Ideal coherent source is a source with one wavelength only, non-chromatic, which does not exist in practice. Practically, there is no fully coherent light or fully incoherent light, but there are light sources with different coherence degree. Now, types of interferometers which are used for measuring or for used in these workshops or in meteorological labs are Michelson's interferometer, Fabry-Perot interferometer, fringe counting interferometer, NPL flatness interferometer, Peter NPL interferometer, Zeiss gauge block interferometer, multiple beam interferometer, and laser interferometer. Now, this is one of the most important uh, interferometer is used here for finding out the flatness. This is the light source is there. This light emanates from this source, and it is focused on this condensing lens. Then condensing lens through this green filter and a point pinhole. The rays are pass through this condensing lens to green filter and to pinhole, and from pinhole these rays are directed towards the workpiece, and the workpiece then passes these rays through these collimating lenses on the glass plate reflector, and through glass plate reflector the glass plate reflector will then redirect these rays towards the eye. The light source is there. Light source will provide the rays which will come in contact with condensing lens through pinhole. These will be directed towards the work part, and from work part these reflected rays will then go through optical flats to the glass plate reflector. Through plate reflector these rays will be redirected towards the eye, and through these eye you will be able to see various fringes or patterns on the workpiece, and through analysis of these patterns then you can find out what are the problems with the flatness of that particular workpiece. These are some of the points which we have discussed in today's lectures. I hope you must have got an idea about the types of instrument, that is precision instruments, non-precision instruments. Similarly, basic idea about the interferometer. Thanks a lot for attending and attending this program. Thanks a lot.
Miguel.